Okay, let's talk a little bit about vector word problems. The first thing you need to know is a few kind of definitions or how to interpret questions so that you know where to direct your work. First thing is every vector word problem will have at least two things mentioned in that problem. Always has to have some kind of object that we're tracking the velocity, the direction of, and then there will be at least one outside force that changes that direction or changes the speed, and we want to see what that results in. Like, what is the final motion that is happening with that object? So, in all the problems we've done so far, there's only been one outside force. Technically, you could have multiples. That's more realistic if you were doing an actual experiment, for example. So, for some of the examples that we've looked at, objects would include things like airplanes, boats, a ball moving around the ground. Anything that can be in motion is a potential object for a word problem. And then we have outside forces. These are things that are going to impact the object and change its motion in some format. So with airplanes, we usually talk about wind or crosswind. With boats, we usually talk about water movement because the boat is impacted by the water. With a ball rolling around a hill or rolling down a slope, you might have wind or water or friction or something pushing it or kicking it or some kind of outside force. So kicking, pushing. This is getting into more physics and more advanced problems. Friction, those can all be outside forces. For the most part, the ones we're looking at are the airplanes and the boats, just because they're the more simple ones. They don't have as many outside forces going on all at the same time, but anything is really a potential. So then we get into some key phrases. These you absolutely have to completely understand. This is probably where most of the trouble is coming from, because if you don't know what it's asking for, it's really hard to interpret what to do with the information you've been given. So the first thing is this phrase right here: velocity of whatever object with respect to whatever outside force. So that changes depending on the problem. This always means give me the velocity, which, remember, velocity is always a vector. So give me a vector without considering the outside forces. So this is the vector of just the object. So whenever we first get our problems, they usually tell us the airplane or the boat is going in this direction, and there's also a crosswind or cross water pushing it to the side. Here we're asking for just what is the boat or the airplane doing if there was no outside force. We just want the vector of just that one object, and that's it. Sometimes that's given to you and you just have to give the components, the component form, so you have to find the two components. Sometimes that's actually what you're solving for, but in every single case, that's what it's asking for. We might also see it worded differently. So I noticed in, for example, in example 2 on the worksheet, it says express the velocity of the water in vector form. I think that's the only one. Everything else is saying with respect to. But it can say a phrase like this: velocity of an airplane or velocity of the wind. And basically what that's saying is exactly the same thing. Give me the velocity vector in component form of just the thing that I'm listing. So it could be find the velocity of the airplane. That means give me the velocity vector of just the airplane. Give me the velocity of the wind. So you're going to tell me a component vector of just the wind only, not including the airplane at all. Not including any other forces, just the wind. So these are all asking the same thing. Then we get into other words. I noticed on your homework on Math Excel, it starts to word these quite differently, but you need to know that all synonyms of resultant or true are going to work the same way. So if you see resultant velocity, resultant vector, true velocity, sum or total or any other words that mean those same things, they're all asking for the velocity of the object after we've considered all outside forces. Now the way to figure that out is always the same. You always just take the object vector which is the one we found here in this step, and you take the forces vector, which was kind of what we did here, and you just add those two vectors together. So just a really quick review. Oops. And I don't have whiteout with me. Let's say this is our vector for the object, A1, B1, and this is our vector for the force. When we add them together, we're adding their components, A1 plus A2, B1 plus B2. And that is your true velocity, or resultant velocity, or total velocity, or velocity after considering the force. Whatever way they want to phrase it, you're just going to add those two together, and it gives you what happened to the object after it was moved or pushed by something else. Then we have another phrase called true speed, which we had in our notes and is on the worksheet, but you may see something like observed speed, or speed observed by a bystander, or the resulting speed, because they use the word resultant up here. Anything that is talking about the speed of the object after you've considered the force is only asking you to find the magnitude of the resultant vector that we just did up here. So all this is asking for is the magnitude of the vector in the previous problem. So once you have found the vector that describes the velocity of something, if you want the speed of that thing, you just find the magnitude of that vector. So whether it was asking for the speed of the object to begin with, in that case you would find the magnitude of the initial velocity vector. If it wanted the speed of the force, like speed of the wind, then you would just take the magnitude of the velocity vector for that force. Most often we're asking you to find the speed of the object after you've considered the force, so that would mean this vector right here, finding the magnitude of the true velocity vector. So now let's do a couple of examples. What I'm going to try to do is not do them for you, but set up the problems and show you what we're looking for in each question, and hopefully you can start to piece that together. So the first one is, I think, a little straightforward, so I'm going to skip down to question number 2 on the worksheet. There's a boat that leaves the Mississippi River with a bearing of 300 degrees. So the Mississippi River, since it's saying east bank, that means there's a west bank. So the river is going to be facing or flowing north to south. So here's our north, east, south, and west. Now, just like on our word problems in last semester with bearing, as soon as something is leaving, you are looking at a compass and you're imagining yourself right at the center of that compass. So if our boat is leaving the east side, then our compass is going to be centered around that point where he's leaving from or launching from. So that's going to be where my crosshairs are. So he's leaving the east side. He has a bearing of 300 degrees. So I go from north around 300. So that means he's going to be going north. And if this is 300 and this is 90, 180, 270, that means this gap right here is 30 degrees. And this one is 60 degrees. The ferry is traveling 10 miles per hour relative to the water. So that means just the boat, without considering the water, is 10 miles per hour. And we just talked about how speed is the magnitude. Speed is magnitude every time. So the magnitude of this vector that I just drew, the length of it, is 10. Given that the velocity of the water is 4 miles per hour, again, speed is magnitude, so the length of that is going to be 4, and it's going towards the south. So from here, I'm going to draw this one in blue just because water is blue. It's going straight south, and the magnitude or the length of that vector is 4. Okay, so that's the entire setup. Hopefully you can see where I got everything from, and hopefully I explained the bearing and why that's the center of our compass well. Now let's just talk about the questions and what they're asking for. So A, express the velocity of the water in vector form. So if I look back in my little cheat sheet right here, express the velocity of a force. That means all they're looking for is the vector in component form for just that force only. So for A, we want the vector for water only. So it should be in component form, A1, B1. So there should be a horizontal component, meaning how far left or right does that blue vector travel. And there should be a B component, meaning how far up and down does that vector go. So you should be able to fill in the two parts for that just looking at your picture. And that's the answer for A. That's it, the vector. B, find the true velocity of the ferry boat. True velocity is when we're considering the velocity of the object and all outside forces. So we need the object's vector, which we haven't found yet, so you do have to do that as part of B. And then we add to that the force vector, which you have just done with part A. So you've already got that one done. And you add their components together to get the true velocity, the velocity of the boat with the water impacting it. So for B, the first step you have to do is find the vector for boat only. You have to do that, otherwise you can't add them together. So that again is going to be two components, A and B. Remember, components are the legs of the triangle. So we've got a hypotenuse here. We need the two legs. So if I drop this straight down, A is my horizontal and B is my vertical. I've got the angle inside. I've got the hypotenuse. You know trig ratios that you can use. If we're solving for A, I can use cosine of 30 because that's the adjacent and that is the hypotenuse. And if I'm solving for B, I can use sine of 30 because this is the opposite and that's the hypotenuse. So either way, solving for A and B, you'll fill those in right here, and that tells you all about the boat on its own. Step 2 is when you're trying to find the true velocity, which means you're going to add water vector from part A plus boat from part B. And once you've found that new vector, you're done. Question C, find the true speed. True speed down here means you have to find the magnitude of the resulting vector in the previous step. So true speed means magnitude of true velocity. And you were just asked for true velocity, so that would be whatever vector you got in part B. You just find the magnitude. Remember, magnitude is the length of the hypotenuse of the triangle formed with these two legs. So you've got your A and your B, and we just used Pythagorean theorem to solve for the length of the hypotenuse. So this was our formula that we used. A and B coming from the vector that you got in part B. Let's compare this to other questions, or let's set up, I guess, the other questions. So number 3, we have another boat heading in a direction 72 degrees east of north. So we would go from north out 72 degrees. There's our boat. The speed of the boat is 24 miles per hour. So again, that's the magnitude. Water is flowing directly south again. So all of this setup is almost exactly the same. It is observed that the true direction, that's another phrase we haven't talked about, true direction. Every time you see true, it's really talking about what is the boat doing when they've already considered the water. This is what the boat intended to do. This is where the captain directed the boat. But there's water pushing it down, so the boat's actually going to be doing something slightly different once you've considered water. This is the direction of the boat with water. So you need the direction of true velocity vector. Now remember, true velocity, this is all just writing down the same stuff we've already talked about. True velocity is the boat plus the water. This is going to be the key to solving this problem. Just that definition right there. The true direction of the boat is directly east. So let me get another color. When they observe our boat, it's actually going exactly east. That's our true velocity. Express the velocity of the boat relative to the water. That means just the boat in component form. So part A is just looking for vector of boat only. So you've already got all the information. Again, that just means you need to find A and B the same way you found them in the last problem. So that's going to be A, comma, B. That's our vector. That would be your answer for part A. Part B, find the true speed of the water. True speed, once again, means magnitude of vector. So you have the vector for the water. You just need the magnitude of the vector for the water. Now that's not obvious because they didn't tell it to us, but we do know the true velocity is directly east. So what I'm going to do is write down everything I know. Since it doesn't seem very obvious to me, what do I need to do to get the information about that blue one? So let's just write down everything that we know, just like we did in class when we got to one of these problems. The true velocity vector, TV, is pointing directly east. I don't know how far, so that's one of my unknowns, but I do know it has no vertical component because it's exactly east. So I know it has a horizontal component and it has no vertical component. Now I'm going to do one for the water. For the water, it's perfectly vertical, so it has no horizontal component, but it has a vertical component. And now we also have our boat. And this you should have found in the previous one. So this is going to have two numbers. It's actually got values for those. Now remember, to find true velocity, you just add W plus V. So if I have numbers for these, and I add straight down, B, which is a number, remember you will have already found that number in the previous problem. B plus B1 equals 0. So B equals negative B1. So if you already have B, let's say it's 5, then you know B1. So you already know a lot about that water vector without even knowing that number being given to you. So if you know B from part A, B1 is just the opposite. And that's actually all you need to answer part B, is just that B1. But if we need in the future, maybe in the next question, to know something about that true velocity, we can also do the same thing over here. A plus 0 equals A1. So again, I know A. If I did part A, I know the value for A. So again, let's just say it's 7. 7 equals 7. So A1 is going to be the same as A, no matter what A is that you got. So once you find these two numbers, you've got these two numbers, and you can fill in all the vectors at that point. So part B is asking for the magnitude of the water. Once you've got water vector, it's 0, and then whatever you get from this equation here. The magnitude, again, is just that formula that we got from Pythagorean theorem. So 0 squared plus b1 squared. And you got that number right there. So you will be able to solve for that. Part C, find the true speed of the boat. True speed equals magnitude of true velocity. And I just said, if you've got this number, which you should have had from part A, then you have this one, which means you've got that entire vector already done for you. So part C is just asking you for the magnitude of that green one. That means you need magnitude of TV, square root of A1 squared, plus 0 squared. And you've got all of those numbers. You have to do part A first. Once you have that, you're filling into these equations and you've got all of your parts. So every single time, what I recommend is when you think you're stuck, when you think you don't have enough information, write down everything. And if you remember this one definition, or two definitions, I guess, true velocity is boat plus water, or plane plus air, or object plus force. True velocity is always that addition problem. You will always have everything you need. And I think that should help with number 4 as well. As usual, send me an email, leave a comment, anything you need to do if you need any further help with these problems. Thanks.